Here we have a SETI math problem. Okay, let's go to the question. In the isosceles right triangle above, AB equals to BC equals to 10 times square root of 2. Points D and E are the midpoints of AB and BC respectively. What is the area of the shaded region? Okay, here we have to get the area of this shaded region. Okay, we have the length of this AB, that is 10 times square root of 2, and D is the midpoint of the line segment AB. Since D is the midpoint of AB, so this midpoint D will divide the length AB, that is 10 times square root of 2 into two equal parts. So that is to get the length of this BD and this AD, we have to divide this 10 times square root of 2 by 2. Then I'm getting 5 times square root of 2 over here and 5 times square root of 2 over here. And the same thing we have for the side BC as well. So because for BC also we have the same length 10 times square root of 2, and this E is the midpoint of BC. Then this E will divide the total length of BC into two equal parts. So when I divide this 10 times square root of 2, the same thing, that is the length of B is 5 times square root of 2. The length of EC also the same, 5 times square root of 2. Okay, the question says it's an isosceles right triangle. Here we have right angle at the vertex B. So in any isosceles right triangle, apart from the right angle, so the two remaining interior angles will be equal, and the measure of each interior angle will be 45 degrees. So here we'll have 45 degrees and here we'll have 45 degrees. So because when we add 45, 45 and 90, so the three interior angles add up to 180 degrees. Okay, here we have a right angle. So on this side also we'll have a right angle, and let me mark this point as F. Okay, here this is right angle and this is 45 degrees. And let's consider the triangle ADF over here. What should be the interior angle measure over here? This one has to be 45 degrees. So that when we add 45, 45 and 90, they will add up to 180 degrees. That is the sum of the three interior angles of any triangle is equal to 180 degrees. Okay, here we get 45, 45 and 90 special right triangle. Usually in a 45, 45, 90 special right triangle, so we assume x as the length of each of the two equal legs. Actually, the leg AF and DF are equal because both of them are opposite to the same interior angle measure, 45 degrees. So we assume x as the length of each of the two legs. That is, let's assume x as the length of this leg AF, and the same length will have for FD as well. In that case, what is the length of the hypotenuse AD? Because AD is the hypotenuse, it's opposite to 90 degree. Okay, so when we assume x as the length of each of the two equal legs in an isosceles right triangle, the length of the hypotenuse has to be x times square root of 2. That is the length of this leg has to be multiplied by square root of 2. So I have to remember this one as a rule. But already we know the length of the hypotenuse AD, that is 5 times square root of 2. But here we got it x times square root of 2. So both x times square root of 2 and 5 times square root of 2 represent the same stuff. So then we can equate them. When we equate them, at the place of x, what do we have? We have 5. So therefore the value of x is 5. So now we can replace the x over here and here by 5. So here we have 5 and here we have 5. Okay, so here we know that D is the midpoint of the side AB, E is the midpoint of the side BC. So this D is the mid segment. Always the mid segment is parallel to this side of the triangle. So clearly DE and this one are parallel. Okay, let's consider this line segment DF and this line segment. Let's say here it's D, it is DF and EG. Okay, both of them are perpendicular to the same line segment AC. Whenever two lines are perpendicular to the same line segment, they must be parallel. That is this DF and EG must be parallel. Already we know that the DE and FG are parallel. Now we know that the DF and EG are parallel. And also here we have right angle, here we have right angle. Then this shape DEGF must be a rectangle. Since it's a rectangle, opposite sides are parallel and also equal. Already we know that DF is 5, then the EG also must be the same length 5. Okay, here let's consider the triangle we have over here. That is CGE. Okay, here we have right angles. On this side also we must have right angle. Here we have 45 degrees. Then what angle measure should we have over here? The same 45 degrees, because the three interior angles of a triangle must add up to 180 degrees. Again, we get a 45, 45, 90 special right triangle over here. So, it's and also it's an isosceles right triangle because two interior angle measures are equal. So the sides which are opposite to the equal angles must be equal in length. So this side of the triangle is opposite to the interior angle measure 45 degree, and this one is also opposite to the same interior angle measure 45 degree. Since this side and this side are opposite to the same interior angle measures of 45 degree, so this leg and this leg must be equal in length. So it has to be 5. Okay, now what we can do is we can get the area of this triangle, And also we have to get the area of this triangle, then we have to add the areas of all the three triangles to get the area of the shaded region. Okay, so let's consider this triangle, the triangle at the top over here. Actually, it is also a right angle because we have a right angle over here. Okay, so in a right triangle, apart from the hypotenuse, actually D is the hypotenuse, apart from the hypotenuse, in the remaining two legs, BD and BE, one of the legs can be taken as base and the other leg can be taken as a height. Okay, first let me get the area of this right triangle over here, that is triangle 1. So the formula is 1 half times base times height here. So for these two legs, one of the legs can be taken as base. So we can take 5 times square root of 2 as a base over here. What is height? The height is also the same. That is 5 times square root of 2. Okay, now I got the area of a triangle which has been numbered 1 over here. Okay, now let me number this triangle as 2. Okay, now let's get the area of the triangle number 2. So here clearly the base is 5, the height is also 5. So the same formula again, 1 over 2 times base is height 5, sorry, and the height is also 5. Now let's get the area of the triangle over here. Let me number this one as 3. Now the area of triangle number 3 is 1 half times base times height. So the base is 5, the height is 5. So then we get 1 over 2 times 5 times 5. Okay, so this is the area of triangle number 1, this is the area of triangle number 2, this is the area of triangle number 3. So when I add the areas of all the three triangles, I am getting the area of the shaded region. Okay, here 1 over 2 times, when I multiply this 5 and 5, I am getting 25. And when I multiply the square root of 2 and square root of 2, I am just getting 2. Okay, positive. 1 times 5 is 5, 5 times 5 is 25, that is 25 divided by 2. Positive, the same thing we have over here, that is 25 divided by 2. Okay, here this 2 will cancel out. Okay, 1 times 25 is 25. When I divide 25 by 2, I'm getting 12.5. Okay, here also we have the same value, 12.5. Okay, here when I add these two values, I am getting 50. So that is the area of the shaded region is 50 square units.